Hello guys. Today we are going to discuss about a problem that is to sum two input array is sorted, where the input array is sorted. Okay. Now coming back to the question, what we have is the array is sorted here. Okay. What if we have unsorted array? That will look in the next questions. For now, it is being given in the question, that is the array is in non-decreasing order. That is obviously it is in the ascending order. Before this, I will make you understand about what is this one indexed array of integers. Okay, so what basically is one indexed array? Generally, what we know is array, the structure of array, what we have learned in our college or schools, is the array starts with the zeroth index. Okay, array starts with zeroth index, we know this, right? But in the question they have given one indexed array, so the array starts with first index, that is not with 0 but with 1, 4. Okay, so we can make zeroth index into one indexed form by adding plus 1 to the each indexes of zeroth index. How? See here, we have added plus 1, we got 1. We added plus 1, we got 2. We added plus 1, we got 3. Likewise, we have converted the zeroth index into one index. So keep this in mind. It will be helpful in the upcoming solution. Now the coming to the question, what it generally says is we have to take up sorted arrays. Okay, so we have given a sorted array, we have to find two numbers sum that is will be equal to the target given, and we have to return the indices of that two numbers. Okay, we have to return the indices of that two numbers. Hopefully you have understood the problem statement. Now let's jump into the solving problem. Okay. So I have taken this unsorted array. Let us discuss about what is the approach for unsorted arrays. So for unsorted arrays or sorted arrays, both, we can apply brute force. The first foremost solution is brute force. So what does brute force means? That is, one will be compared with each element, and the target is being checked. 1 to 5, 1 to 0, 1 to 2, 1 to 7, 1 to 11, 1 to 15, and again 3 to 5, 3 to 0, 3 to 2, 3 to 7, 3 to 11, 3 to 15, 5 to 0, 5 to 2, 5 to 7, like this it goes on till it will be order of n square. Okay, the brute force solution which I am talking about will give the time complexity order of n square. How? Let us see. Outer loop will run, that is I, from 1 to n minus 1, and the inner loop will run from I plus 1 to n minus 1. Okay, and then we have like a condition: if nums of I, okay, plus nums of j is equals to target, then we have to return. Okay, here what we have to return, pause the video and comment down. Okay, so here what we have to return is I plus 1 and j plus 1. This is the will be the solution for the brute force. Okay, this is the solution for brute force. Okay, but it will take the time complexity, as I said, order of n square. So what is the optimal approach? What is the optimal approach? So This sorted array, we know how to like approach to this question with the brute force. Now coming to the sorting part, to this above question, array is sorted. We have to take another example, that is, let me clean this first and I will take an example. So as the question itself says, that is array is sorted already, or else if the array was given unsorted, we have to sort it first, then we have to apply this optimal approach. It will take you n log n if the array is unsorted. If you sort it, and then we have to try to uh, apply this approach. Okay. Now this is sorted, right? 1 3 no, 1 2 3 7 11 12 15. Yeah, it is sorted. Now it is sorted, right? What we do is we maintain two pointers. One is the leftmost pointer and one is the rightmost pointer. The question is of the two pointers. I will write down the question. The pattern is, I'll write down the pattern here. Two pointers. Okay, now let's discuss the problem of the optimal approach. So basically what we do is we'll calculate the sum, that is nums of L plus nums of R. It will, then we have to check if sum is equals to the given target. If it is yes, then we have to return the indexes, that is L and R, in L plus 1 comma R plus 1 form. Okay. And if not so, then we have to just return, else we have to return -1 and -1. That is no two numbers is present in the array that add ups to the given target. Okay, this is the basic intuition of this optimal approach. Now let us discuss how we apply this into our solution. Okay, this is left and right. 1 plus 20 is equals to 21. 21 is equals to 9. Now comes the most important part. Now we got this has 21, right? Now which pointer we have to move? We should move the left pointer, or we have to move the right pointer, or we have to move both. So if we move both, the problem will be, that is, we'll skip an iteration, that, like, if the suppose if the like we can say the target is 22. Now the right one is wait a second. Okay, if the target is 22 and the right pointer is here and the left pointer is here, if we move both the pointers, I'll move left to here, and likewise simultaneously I will move the right pointer. By this I will never get 22. I will never get, hoping that in this array that 22 is not the two numbers will not add. Okay, in this array will not get 22 because we have skipped here. So what would be the condition? There should be a condition to move left and right pointers. So the condition is, if the sum is greater than the target, then the sum is greater than the target, right? Yes. 21 is greater than 9. Yes, obviously we have to move the right pointer, else we have to move the left pointer. That's the basic intuition of this problem. Okay, now see why we are moving the right pointer when the sum is equal greater than target. Why? Because the array is sorted. The catch here is the array is sorted. Okay, if I move left pointer, okay, if suppose if I move left pointer, it will be 20, right? 20, 20 plus 1, I got 21. If I move left pointer, then it will be the sum will increase, right? 20 plus 2, it is 22. So it's away, it's going away from the target, right? But when I shrink this right, that is right pointer here, what I am getting is 15 plus 1, that is 16. 16 is closer to the 9, right? So we are going to our solution. Okay, this is the intuition. Hope you have understood about the working of the pointers and this condition. Okay, okay, now what we do is uh, we move the pointer, that is right pointer here, and again we have to check. I will make this here. Okay, now again we have to check. 1 plus 15 is equal to 16. 16 is not equal to 9, so 16, that is sum is greater than target. Yes, shrink right. Again 1 plus 12 is equals to 13 is equals to 9. No, shrink the target right, that is right. 11 plus 1 is equals to 12. 9, no, shrink the right. Then 7, 1 plus 7 is equals to 8. 8 is not equal to target, but here the sum is less than the target, so we have to move the left pointer. Now it's the time, it's the timing of left pointer to move forward. Now 2 plus what we have, 7 is equals to 9, that is equals to the target. Yes, then we have what we have to do is return the indices of it. Suppose the indices are like 0 1 2 3 4 5 6 7. So what is the index of 2? That is 1, and 7 is 3. We have to return 2, no, like 1, 1 and 3, right? 1 and 3, we have to return it. No, we have to return 1 plus 1 and 3 plus 1. So that is actually the left pointer and the right pointer. We are returning the left pointer and adding 1 to it. Or else what we have to return, minus 1 and minus 1. We are using pairs to return it. So let's jump into the solution and try to code this in the environment, and let's check the test cases and check our solution is working or not. Let's try this. So now we are in the coding environment. Now let's start coding. First we have to initialize our pointers, left and right. Left will be to 0 and right is numbers dot size. Okay, minus 1. Then we have a while loop, that is left should be less than right always. If the both arrays process each other, then it will stop iterating. Okay, the next thing is we have the condition. If we have to calculate sum, in sum is equals to numbers of left plus numbers of right. Yes, Then we have if sum is equals to target, what we have to do is return left plus 1 and right plus 1. Then we have the condition to move the pointers. I'll write it here. Condition to move pointers. Okay, if sum is greater than target, okay, then we have to decrease the right pointer, and else we have to increase the left pointer. Or else if there is no two numbers existing in the array that sums up to the target, then we have to return just -1 and -1. Okay, that's it. Now let's test it. Okay, before that we have to check any semicolons are missing. No, right? Oh, okay. It perfectly works fine, hopefully. Let's see it. Okay, what is this? Okay, now it works, hopefully. Yeah. Your input is 2 7 11 15. Input is 1 comma 2. Expected answer is 1 comma 2. Okay, beautiful. Now let's submit the code to the LeetCode. Yeah, it has been accepted all the test cases. Okay, thank you. uh Hopefully you have liked this video. If you want more, then subscribe, like, share and subscribe. Comment down below how I can improve, and which problems you need the solutions. You can uh, type in the comments. Thank you.